Okay, good morning, everyone. So I'm going to be talking today about looking at climate change and the influence it's having and can have on water quality in Ireland. So this work was funded by Forum Uisce, and on your desks you'll see there's actually a nice policy brief which has a look at climate change impacts on Ireland's water resources if you want to have a look at this. This research was also done with numerous suite of colleagues in environmental science in UCC as well. Okay, so thanks everyone for coming. I just wanted to say that water is so important to life, to our society, our environment and our economy, and we really can't escape it, whether it comes in liquid or even solid form, as you can see on the roads today. So I want to start a little bit about talking about water quality today and where we're at. So in terms of our water quality, around 54% in our rivers, our lakes, our transitional waters and our coastal waters are considered to be high or good quality. However, that means that 46% are not in satisfactory quality. And this is more than just a statistic. This is having knock-on impacts on our ecosystems, in our freshwater resources. It's also impacting society and will lead to some difficulties in our environmental commitments as well. And you can see from the map over here that we do have these spatial distributions. So what we can see with the yellow colour is that it's water bodies that are in less than satisfactory quality, and the blue indicates high or good ecological status. Now, not all our water bodies are equal when it comes to looking at their status. Our rivers, for example, only 8% are of high status, and we're losing more of these. Okay, so we're on a downward trend, unfortunately. And particularly when we look at our transitional waters, over 64% are actually in poor quality. We have high nitrate concentrations. Nearly a third of our rivers at 30%, and our lakes at 33% have elevated phosphorus. And there are numerous pressures that interact together to give us and decrease our water quality. The biggest one here being agriculture at around 63%. So this includes nutrients, mainly nitrates and phosphorus, also pesticides, soil and suspended sediments getting from land into our waterways, also forestry and activities around that, and peatland degradation all impact our water quality, looking at the export of things like dissolved organic carbon, which I'll talk about in a few minutes, and also looking at suspended sediments from soils, phosphorus and heavy metals. Even looking at urban wastewater, urban runoff, stormwater, they all come together to play a part in deteriorating our water quality. Globally, research on climate change and the influence it's been having on water quality has grown significantly in the last 20 years. So we have a lot of science now to show that changing hydrological cycles, so shifting rainfall patterns, increases in temperature, more extreme weather events, increased evaporation rates, they're all impacting our water quality in various different ways. They can be direct, looking at the transportation, concentration and transformation of different contaminants, and they can also be highly multifaceted and indirect as well. And there are multiple stressors that can come together, making it quite complicated. The impacts can vary by space and by time as well. So you can get pulses of certain contaminants going into water, and other ones can stay there for long periods of time. Okay, so Conor gave a very great introduction into kind of looking at what the climate change impacts actually are. So if we look at just say summers, for example, when we have warmer temperatures and extended dry periods, most chemical reactions and microbiological processes run faster at higher temperatures. So this can be the breakdown of organic material, increasing our carbon cycle, or the mineralization of nitrate, for example. So if you imagine that these are just kind of maybe pollutants, sediments, nutrients that are sitting on land. So you have different processes that are sitting there under warmer temperatures. And if we have lower river flows, lower water levels in summer, what can actually happen is when these contaminants enter into the waterways, they actually become concentrated. And this concentration can actually have impacts, for example, nutrients like phosphorus and nitrogen can lead to increased algae blooms like cyanobacteria, which can deplete the oxygen in these waterways and can also lead to potentially toxins being released, having an impact on our aquatic ecosystems. We also have issues in lakes with phosphorus already, and what can happen in lakes is under warmer temperatures and longer growing seasons, what can happen is lakes tend to stratify, meaning the top layer can be oxygen rich, whereas the bottom layer becomes depleted, which can also lead to the re-release of legacy phosphorus, making conditions in our lakes potentially worse. Okay, so what's going on and what's happening on land is very important for what's going to happen in our waterways. So we've had this brownification that's been happening across Europe and the US, and this is down to something called dissolved organic carbon. And these concentrations have been rising across Europe, and this has been largely due to warming, drought, and also has been linked to increased atmospheric CO2. So I'm talking about this because in Ireland we have a lot of organic soils. Peatlands particularly cover 21% of our land area. No fully natural peatlands actually remain in Ireland. And there's been evidence to show that, in some of the studies I've been involved in, looking at a paleo-ecological perspective, show that our peatlands in Ireland and also across Europe are actually drying out. So even if we don't look at the human activities on peatlands, what's actually happening is drawing down of the water table exposes those upper layers of the peat to oxygen, which means that that carbon that's within the peat is being broken down, released to the air as carbon dioxide, but also released to water in the form of dissolved organic carbon. Now, in Ireland, we have no fully natural peatlands that are left. We've actually have a lot of conifer plantations on peat. We've also degraded our peatlands, and I probably don't need to talk about what we've done because they're usually front and centre stage. But climate change, on top of the activities that we've been doing to peatlands, is exacerbating this DOC withdrawal. And myself and Gino Dwyer and other academics in UCC have a project looking at this at the catchment scale. Future climate change and projected climate change with warmer, drier summers will likely lead to more DOC withdrawal. Why do we worry about this? Because this could actually increase an elevated DOC in water, will actually pose challenges for our water treatment as well. Why is this? Because DOC reacts with chlorine, a common disinfectant used in water treatment, and it can form these harmful disinfection byproducts. So there's a suite of them that it can form, one of them being trihalomethanes. Okay, and this has been linked to cancer in kidneys and livers. Now, it's highly regulated by the European Union. However, Ireland exceeds this. We're one of the top countries that exceed in Europe. A great study was done in 2008, and what this graph shows on the left in the green is peat presence, so mostly blanket bogs here, rain over 1,400 millimetres, and slope below 5.25. The graph on the right shows THM exceedance levels, and you can see there that there is a clear link with our peat and our THM exceedance. Our limit in Europe and in Ireland is 100 micrograms per litre, so the purple and blue there indicate exceedance levels. If we even look at the red, the limit in the US is 80 micrograms. Okay, so we've got huge issues coming down the line with potential increased DOC as a result of climate change and our PT catchments. Okay, so also when we have heavier rainfall events in our winter and autumn months, this can lead to contaminants that have been building up on land over the summertime to actually get their way into the waterways. And you'll have more energy with more rain, pushing more sediments, these nutrients in. Okay, and there's been a lot of work, a lot of different studies looking at this pulse of contaminants that get released after heavy rainfall events. I haven't talked much about groundwater. I'll let Jean O'Dwyer do that because that's her expertise. But also I did want to mention it because changes in our climate, our extreme events, our water, how it makes its way into the ground, particularly soluble contaminants, and how they move around within here and whether they go back and recharge into our waterways or whether they go back out to the ocean. So we need to kind of have a look at and be looking at drought and vulnerability within our groundwater resources as well. Just wanted to quickly mention, and I've been focusing a lot more there on I suppose, natural kind of parts of the upper landscape, but also in our urban environments we have major challenges as well, particularly with flooding. From a water quality perspective, we have a lot of combined sewer overflow in Ireland, so which means that water from our storms or even just from our rain goes into our sewers and is actually combined with sewage from domestic and commercial sources as well. Now, this all works well and good in dry and light rain conditions. However, when we get wet weather, what can happen is that water that would have originally gone and been sent to a water treatment plant, in order to stop it backing up onto roads and people's houses, it's released directly into the environment. And this is the system that we have in Ireland, unfortunately. What we could move to now in the bottom graph over here is actually separating out our stormwater from our sewage system. Going further, we could actually implement some sustainable drainage systems, such as constructed wetlands and even rain gardens, to give them some level of treatment. They do this really well in Australia and New Zealand as well. They've been implementing a lot of these types of solutions, and they work very well, not just from a water quality, but also quantity as well. So it likes to retain and hold that water. What do we need to do? Basically, we need to be having a look at how interconnected our catchments are, right from the source right down to our river, or right down to our oceans as well. We need to be looking at changing climate and the altered weather patterns that that's having regionally. What are the land use that's going on within the catchment? What are the different pressures? And also the soil and how that water moves through the landscape, whether it makes its way quickly to surface water or groundwater. It's also important to remember that catchment plans should be tailored as well. What would work for maybe the northwest of Ireland might not work for the southeast. Catchment management plans need to be adaptive as well. They need to account for things that maybe we haven't anticipated that would that would be due to climate change. So they need to be in some way flexible, and they need to be solutions focused, whether that's more investment in our water infrastructure, separating out our stormwater, and also implementing nature-based solutions as well. Other parts of Europe are much more leading in this than Ireland. And also we need to have a long-term perspective as well. Because we need to actually, if we implement solutions, they need to be trialled, they need to be scaled up, and this will take many years for this actually to happen. Okay, well, thank you very much for listening to me.